Circular coil of 30 turns and radius 8 centimeter carrying a current of 6 ampere is suspended vertically in a uniform horizontal magnetic field of magnitude 1 Tesla. The field lines make an angle of 60° with the normal to the coil. Calculate the magnitude of counter torque that must be applied to prevent the coil from turning. And in part B, would your answer change if the circular coil were replaced by a planar coil of some irregular shape? And it has the same area 30 and radius is 8 centimeter. I can write it as 8 into 10 to the power of minus 2 meter, or we can also write it as 0.08 meter as well. Then the current is given as 6 ampere, is given as 1 Tesla. The field lines make an angle of 60°. So theta is equals to 60°. These are the magnetic field lines, and this is from the top section. We are not seeing this from the side. If you are going to see it from the side, it will be appearing just like this, and it is not going to make any sense. So if I show you the top view, ಮೇಲ್ಗಡೆಯಿಂದ ನೋಡಿದಂದ್ರೆ ನಿಮಗೆ ಈ ಪ್ರಕಾರ ಕಾಣಿಸುತ್ತದೆ. And this is the plane of the coil, and the normal is going to be drawn like this. So this is the normal to the plane of the coil, and the angle between the magnetic field and the normal to the coil is given as 60°. So this angle is given as 60. Equation of torque, tau is equal to n, or I can take it as small n for this one, I A B, and that is the equation for the torque. And this is because angle is given, you have to use it as sine theta. So that is the equation. But in this equation, one term is missing, which is not available with us. We have the n, we have the I, we have the b, and we also have the theta. The a part is missing, which we have to calculate from this radius. Area, directly I can apply a is equal to pi r square. So it will be pi into 8 into 10 to the power of minus 2 whole squared. If we simplify, I will get it as 2.01 into 10 power minus 2 meter square. Need the diagram. So that is the area we have calculated. Now we have all the terms which are required, so we can directly substitute it as tau is equal to n I A B sine theta. So this is going to give me n is 30 into I is 6. Area we have just calculated 2.01 into 10 to the power of minus 2 Tesla into sine theta, that is sine 60°. It is root 3 by 2, but I am going to write it in the form of decimal form 0.866, that is root 3 by 2, 3.133 Newton meter. Part B is, would your answer change if the circular coil in part A were replaced by a planar coil of some irregular shape that encloses the same area? If we are getting the same area, then the value of the torque will remain same. That is one thing. Then the second thing, another point which is to be highlighted in that part of the part B of the question is planar area. They have clearly mentioned. So it should be a plane area, it should be a flat surface. Only then we are going to get the same amount of torque. Since the area does not change, the magnitude and direction of the torque same. So that will be the answer for the part B of the question.